All right, so this last video that you guys are watching today is going to finish up chapter 7 for us. And so if you guys turn to the very back page, 7.6 notes is what we're going to do real quick. This should be a quick video and also a quick homework assignment that goes with it. So the first part of our notes is just talking about something called the principal branch. And so we've had lots of conversations about the inverse trig functions. And if you think about sine, cosine, they have waves like this, so their inverses are waves like this, if you were to reflect that. Well, the issue with that is fails the vertical line test, they're not functions, and so when we ask our calculator for sine inverse, cosine inverse, tangent inverse, we only ever get one answer. And so this is how mathematicians decided what answers to program the calculators to give us, and the pieces of the inverse that they kept are called the principal branches. So the first criteria in how they selected which answers our calculator would give us is, of course, we want the principal branch to be a function. Also, it must use the entire domain of the inverse trig relation. So what that means is we want to be able to plug in ratios from -1 to 1. And so with sine and cosine, we have to go all the way to the left and all the way to the right of the graph. And then with tangent, obviously that goes from -infinity to infinity, but we had to make sure that we use the entire domain. Number 3, it wanted our principal branch to be one continuous piece. And so instead of pulling answers from maybe somewhere over here and somewhere over here, they just wanted one nice piece to restrict our inverses down to. Number 4, and this is something you guys have already kind of caught on to, is that our calculator gives us small answers. And so that just means that they wanted to keep these principal branches as close to the origin as possible. And so that's what number 4 is, centrally located near the origin. And then the last one, like all the criteria that I just listed, there's technically, if you look at cosine, if you were to just highlight this bottom piece, that would meet all of the 4 criteria. And so that's why with number 5, what it's asking is if there is a choice between 2 possible branches, use the positive one. And that's because if you think about where trigonometry is more commonly used, it's in basic right triangles, and angles make sense to be positive in basic right triangles, and so by default we want positive angles out. So that's kind of the background of how and why our calculators give us the answers that they do. So moving on, we have 4 examples. The first one is asking us to evaluate tangent of sine inverse of -2/3. And right here, this term here geometrically means draw a picture. Again, when we see exact value, we want to avoid our calculator. Now, we could absolutely check our answers by just typing this exactly into our calculator. And this might be where some students ask, well, what mode should we be in? And the answer is, it doesn't matter. Okay? So if you ask yourself the question that I've asked you over and over again, if you think about tangent, what do we put into trig functions? The answer is angles. And what comes out? Ratios. Okay, so what I'm looking for, looking on the outside of this, is I'm looking for a ratio for tangent. That means that what I put inside of here is representing an angle measure. So I'm not actually going to find what that angle is, because looking at this problem as a whole, I just want to know a ratio for tangent. I don't really care what that angle is specifically. It's just explaining a triangle to me. So what it's saying is that this is a ratio that we were putting into sine to get an angle, and at that angle, I want to know what tangent is. So I'm going to call this angle theta. We know that sine has a negative ratio of 2/3, and so my drawing isn't going to be super accurate here. opposite over adjacent, or sorry, opposite over hypotenuse, you could draw a triangle like that. But when you're thinking about sine inverse, it might be more appropriate to draw it down in the fourth quadrant. That would be the angle measure here, -2, 3. And so what we're looking for is tangents ratio here. So we could use Pythagorean theorem. So that would end up giving us 3 squared is equal to 4 plus x squared. So we would have x is the square root of 5. And tangents ratio here is opposite over adjacent, so -2. So really this problem isn't anything brand new to us, it's just getting a little bit more comfortable with that inverse notation, but just keep in mind this is representing a ratio, the inverse is representing an angle, which is inside a tangent, which means we're searching for a ratio. And again, you could type this in your calculator, figure out what it is as a decimal, and then type this entire thing into decimals as well to compare. Okay, so next example, we want to evaluate the secant of the cosine inverse of 5/7. So I'm going to go through and draw a picture, but then I'm going to show you a shortcut of how you could find the answer here. And so cosine inverse is explaining an angle to me, and at this angle, cosine's ratio is 5/7. So that's adjacent over hypotenuse. Well, secant, we think about the definition of secant, is the reciprocal of cosine, so hypotenuse over adjacent. That means 7/5. Okay, so the shortcut, if you recognize that secant and cosine are reciprocals right away, you could take this ratio and flip it immediately. All right, so our last two examples. If you look at both of these, you're going to see cosine of cosine inverse, cosine of cosine inverse. So I'm going to hop down to this bottom one first. And this is kind of a silly question. What this is asking us is, what is the ratio of cosine at an angle where cosine's ratio is 1/2? Okay, hopefully you're thinking, well, the answer is 1/2. If not, let's draw a picture. The inside is explaining an angle where the adjacent over hypotenuse is 1/2. So this is asking us what's cosine's ratio there? Well, 1/2. So essentially when you have a trig function and you have an inverse of that same trig function inside of it, we know that they will cancel, undo one another, and you're left with 1/2. Now, one common mistake on this example is students will go, okay, that means that my answer is 2 here. No, no, no. Okay, try to draw a picture. If you're trying to draw a picture, this means that the adjacent is 2 and the hypotenuse is 1. We know that 2 is too large of a ratio to go into cosine inverse. The largest ratio for sine and cosine is 1. So this one would be undefined. All right, that is it for section 7.6. So the web assigned homework should be pretty quick for you guys. And then we are done with chapter 7.